Oh, okay, good. So we are going to talk today about why it can be so difficult to create good training data for NLP model. So why it can be tricky to create those intelligent chatbot, not just simple chatbot, but intelligent one. And we are going to go back through some basic to start with, because some people still believe that you take an NLP engine and it understands things. It doesn't. So, but a little bit about me, quite boring, but CTO from Volume, 20 years in tech. I did a little bit of work, or quite a bit of work with the space industry, studying not on Saturn, because that would be a long trip, but studying about Saturn. Did some work in the armament industry in embedded software for head of missiles. But the last 5 years in NLP, in conversational AI, has been, amazing from my point of view. And really, our missions at Volume is to turn crapbots into chatbots. All right? All of us have experienced chatbots here. And we have most likely had a lot of bad chatbots, and we have experienced a few good chatbots. And that is not necessarily because the technology is bad, because there's a lot of big players out there providing the technology, open source people providing this technology. It's just we don't know how to make the most of it. We don't know how to extract the best out of those technology. So what we all need to remember, and I'm going to go quite fast here because that's really basic, but those things need to be trained on domain-specific information. And us in NLP, we love to make simple things complex, so we have intents, and intents are very much classes. Lower? Higher? Yeah? Intent are very much classes. Okay, and an intent is very much what does a user try or what do we want to express here. Entity, our name's entity. People tend to say, entity modified the intent. I'll prefer to say clarify the intent. It's not very good, is it? Can I get those on mic? Give me those on mic. I'm going to get another mic in a second. So we have entities and uterances, because again, we like to call things in different ways. Uterances are really much training data. And a few years back, we got some great advice where people said, anything that the user asks, you put it in your training data, it's going to be fantastic. It's not. So we like to say, uterances are just examples, but you have to control what you put there. You have to make sure it's defined to the intent, to representing the intent, not just all user logs. And really, NLP classifier, it's a multi-classifier problems. And in AI, multi-classifier problems are quite well known. So why should it be so difficult? Okay? So let's go through an example. I want to order a box of chocolate. Okay? Here is your iterance. Here is the intent. The intent, it's all about, I want to place an order. And the entity, it's all about, what are you ordering? Box of chocolate, fruits, flowers for my wife, maybe. Here is another example. Show me financial news. So, it's about showing news, but what type of news do I want? I don't want sport news. I want financial one. So this is the premise of what you need to think when you create NLP models. Now there are several challenges. The first one is mechanical. So we discussed the fact that NLP is a multi-classifier problem in AI. Okay? And multi-classifier works very well. If you think about image classifications, we all used it. It's pretty awesome. And, think about the fact that Nowadays, if you have 10,000 images of a dog, of a cat, and of a tiger, your classifier would be close to perfect. All right? Now let's look at NLP. NLP, we saw the intent show news earlier. How many examples can you have of show news? You won't have 10,000. You won't have 1,000. You know, you might have 10, 20, 50, 100 if you get lucky. Okay? So what's happened is we end up in these problems of a low ratio of training data per classes or per intent. And because of that, it creates ripple effect. And ripple effect is very simple. Let's go back to our image classifier, for example. Okay? And let's say we have only 10 images of a dog, 10 images of a cat, 10 images of a tiger. All right? And now we want to improve our cat class because it's not performing very well. So what we do, like in NLP, we add more training data. We add more cat pictures. Great, our cat start to get really classified very well. But how much effect this fixing the cat will have had on the tiger? Quite a lot, because it's very close concept. The animals looks very similar. So this ripple effect is very important because we see so many times people looking at their logs from their chatbot and say, oh, that didn't work, let me fix it. And it's great because in the meantime, my user have a poor experience, but let's fix it. And we fix that. And 3 days later, you find out that what used to work before doesn't work anymore. It's because this ripple effect. Okay? So the second challenge is training data. You know, there are different approaches. Some people say you take all your historical data and you train it. Okay? It's a concept. We don't really advise it personally, but it's a concept. The second thing is, you know, take some of information you may have somewhere and you label it manually. Okay, so you get someone to really understand, you know, the subject matter that you are trying to represent and you label manually. And that's not very good either. It's not very good because we are the people labeling it. And we are, as humans, are biased about language. Because we learn about this language in a way that is completely different than the way the machine is looking at language. The machine is looking at language at you know, in such a different way, and different providers have different way to do it. You have semantic engines, sub-semantic engines, you know, so it's completely different. So what's very important is to have a machine vision, a machine perception on your data, not a human perception on the data. I love to say that, you know, I don't care what you think about the training data, it doesn't matter to my guys. What matters is what the machine is seeing. And once you understand the quality of this training data, you get this kind of lovely effect where sometimes you have to fix your training data that is not performing in a very counterintuitive way. And it's counterintuitive because, again, we are the human, and we have a view on this data. We have an opinion on this data, but we shouldn't. The last challenge you have is mapping. So you need to really map your domains. And mapping the domain is one of the things that is most difficult to do. And you need to map the domain. There is no right recipe to map a domain. So what people tend to do is, or what we do, is really trying to understand what are going to be the initial scope of the NLP. When you have the scope, we are taking a bottom-up approach, which is very much, okay, now I have the scope, now I know what I want this bot to answer. Let's get some idea about what will be the answer. Give me an example of question. Even if the question doesn't make the training data, doesn't matter. Give me an example of questions. And that's very much the Excel spreadsheet here. So we get a sample questions. And after, when we get all our sample questions for the different subject area we want to cover, we start to fill this L1 column. This L1 column is, what is this all about? What is this question about? Okay, this question is about companies. Okay, and now we have, all those sample questions in company. We go to level 2. What type of company? Okay, partner, missions. Well, what is it about the company? Partner from the company, mission of the company, visions of the company, and so on. And then we go level 3, level 4 if we need to. And once we have this breakdown of trying to map the different area of the scope we try to define, then you can start to think about, is that an intent? Is that an entity? How should that be represented? You have also other things that may play a part. Our tools, for example, QBox, is showing you your training data with the intent is the middle circle, the green circle, and all the other intent that are influencing the intent you are trying to represent. And this is very useful because you can see, it just allows you to see if you start to get overlapping about the intent understanding from the machine perspective. So you might be very clear to what you want to say, what those two intents are going to say, but the training data you have is not clear to the model. All right? So now we have talked about those 3 challenges. How do we try to do what do we do about it? And what I don't like is really, and it's quite common, it's really people that says, I have my user and they say this, or the bot didn't react properly. And I'm like, what the hell? You have to test your model before you go live. But how do you test your model before you go live? So you have techniques like, the RASA team, sending to people to test it. But can you not test the performance of your training data even before doing all that? So, we talk, it's a multi-classifier problems typically, and there are well-known techniques for multi-classifier problem. 30-70, so I keep 30% of my data for testing. Some people will call it 20-20-60, doesn't really matter. But we talked about it. We don't have huge amount of training data ready to train the model. So now this technique is asking me to take some away. I'm not going to take some away. I already don't have that many. 2 other techniques, K-fold or Monte Carlo, they are very well known, very good in multi-classifier, but they don't work well in NLP because you are going to do your K-fold, for example. You are going to run a confusion matrix out of it. All lovely, your confusion matrix tells you, you have problem in this area or this area, fine, absolutely fine. And then what you do is you change your training data a bit. You improved it, so on. You rerun a K-fold. Oh, guess what? Your folding is completely different than the previous one. Meaning your confusion matrix is going to be completely different, which has nothing to do with the improvement you made. It has to do that each foldings are so low level of training data. Monte Carlo has exactly the same problems. So what does work? What does work is blind data. Blind data is lovely. If you can have blind data, perfect. But blind data has several challenges. Keeping it blind in English. Keeping blind can be very, very difficult. But if you have some, and if you have spent the time getting this blind data together, it's very, very good. But those tests will only be good as your blind data. Leave one out. Leave one out is great because you don't need any external data. Leave one out is simply, you have your model, you have your 50 intents, you have your 2,000 pieces of training data. And what you do is you take one piece of training data, you don't put it in the model. You don't train the model with this piece of training data from an intent. Okay? And what you do is you ask the model this particular piece of data, and you see where it lands. And you know where it should land. And that's great. But it's very, very, very resource intensive. It's very source intensive because you want to do that for all your training data. Meaning you have 2,000 pieces of training data, you will need to train 2,000 times a model. Okay? And control distribution, personally us, we have done a system which is called control distributions, which give you this kind of statistics here. So correctness, confidence, and clarity. So it will, look at your models and it will say, am I correct in predicting the right output? Oh yes, I'm correct about predicting the right output. Yeah, fantastic. But now, am I confident about these predictions? Because being correct is not enough. You need to be confident about it. All right? So confidence is a very important metric. And clarity. Clarity is even more important and so missed by people. Clarity is very much like, yes, I'm correct, great. Yes, I'm confident. But if the second best prediction is just there, just a little bit behind, so not 90%, but 88, and that's the second one. Am I really sure my 90% answer is the right one? So clarity is very, very important to look. You want gaps. The more you have gaps, the more your intent are well-defined, narrow, and spread over space. So just a few key takeaways. Don't wait until your user uses your chatbot to test your training data. Okay, never, never, never. There are tools for that nowadays, so you should use them. More training data is usually better in AI. That's not true in NLP. We haven't found that true, especially with NLP classifier technology. Machine, this is, if you have one thing to remember is this one, machine do not read language the way we read language. So it doesn't matter what we think, okay? Mapping, doing all your strategy around intent and entity. That's a key, and it's not unusual that people have to do it several times. So you get one, you get your models, it's good, but it will find a limit, and it's because you will have to redo your intent entity strategy. And measure, measure the performance of your training data on your machine. All right?
Okay, thank you, Benoit.